Hello and welcome to yet another installment of the geometry videos. This is section 3 and this is slopes of parallel and perpendicular lines. And so our objectives today, we want to complete the steps to prove the slope criteria for parallel and perpendicular lines using coordinate geometry. We also want to just determine if two lines are parallel or if they are perpendicular, and use the slope criteria to find additional points on a line parallel or perpendicular to a given line. So, if we take a look at this, I've got a, this line P prime Q prime and line PQ. And let's just go ahead and call this line PQ here, and we'll call this line P prime and then Q prime. And what we've done is we've translated this line. So we've translated this line and we've just shifted it over a few units, okay? And what happens is when you translate a line, you get a parallel line, okay? And so what I want you to see here is that once you take a line, and then you just take copy that line and move it over, you get another parallel line. And so I want to find the slope of line PQ. And remember, when we talk about slope, okay, and I'm going to write this up here, slope, okay, often referred to as the variable m, is equal to, we often refer to this as rise over run, okay? We also refer to this as the change in your y value divided by the change in your x. And then we also, use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? So if we were to find the slope of, say, PQ, okay, we'd want to find, if you draw a right triangle, okay, connecting those 2 points, you want to sit there and go, okay, well, from going from one point to the next, what's my vertical change? What's my rise? What's my change in my y value? And that's going from 6 to 0 to -4. This is a value of 10, okay? And then what's our horizontal change? And that goes from 0 to 10 as well, okay? So what we can tell is that the slope of that line, okay, the change in y over the change in x is 10 divided by 10, or the rise over the run is 10 over 10, which is just a value of 1, okay? And then what we notice about P prime, Q prime is that we have the same thing. Okay, we have a horizontal change of 10, and then a vertical change of 10. And so if we take the vertical change, which is 10 divided by 10, we get a value of 1. And these slopes are the same. Okay, these are the same. So what we realize, the conclusion that we can draw, and maybe you already knew this, but parallel lines have the same slope. Okay? And before we move on to any other slopes, to figure out the sign of your slope, I always do this. I always know that my positive slope goes in this direction. I know that my negative slope goes in this direction. I know that when I have a 0 slope, it gets horizontal. And then when it's vertical, my slope is actually undefined and we don't even have a slope. Okay? All right, let's take a look at the next one. And it says use the graph of the lines to determine if the two lines are parallel. So let's just go ahead and find the slope of MN, okay, and let's just draw a right triangle here. And let's go, we went down, this change was 8 units, and I'm getting that number from my scale on my graph, okay. I know it says that it's 4 away, but it's actually 8 because of the scale. And this is a -4, okay, because we're going down. And then the other one, the horizontal change is a change of 4, okay? So, oh crap, what do I do? This is wrong. This would be -8, okay? And then this is 4. Okay, and I'm going to do the same thing over here with this one. I'm going to go down and then over. And my vertical change, again, was a -8, and my horizontal change was a +4. So the slope of that line MN, okay, has a slope of -8 over 2. So I'm going to write -8, over 4, which gives me a value of -2. That's my slope, okay? Slope of M prime N prime is the same thing, okay? That's -8 divided by 4, which gives me a value of -2. And because these are the same, okay, because they're the same, then we know our lines are parallel, okay? And that's it. Okay, now let's talk about perpendicular lines. Now, if you were to take a line and rotate it, say 180 degrees, or I'm sorry, 90 degrees, then you end up getting a perpendicular line, okay? So when you rotate something about 90 degrees, you get a perpendicular line. And that means, perpendicular lines, perpendicular is when you have, what do we got here? Lines that create a 90-degree angle, that make a 90-degree angle. Okay, so then the slope of PQ, okay, and let's just call this line right here, we'll call this PQ, all right, PQ, and then we'll call the other one, say P prime, Q prime, okay? And what I want to do is I want to calculate the slope between PQ. And what I see with that one is I'm going to create a right angle here, right triangle. And so I go from -1, okay, all the way to 3. So that's a horizontal change of 4. And then my vertical change going from 2 down to -2 is also a change of 4. So I know that my slope of Q is 4 over 4, which gives me a slope of 1, okay? And then if I were to come over here and do a one for the other one, P prime Q prime, then going from 1 to -3, that's a distance of 4, and then this distance from 2 to -2 is also a distance of 4. So, but the problem is that the line is going in this direction, okay, which makes it negative. This line is positive, okay? So this one was actually -4 over 4, which gives us a slope of -1, okay? So what we realize from this is that the slopes of these lines are actually, and it's not necessarily just opposites, but opposite reciprocals, okay? So one way to figure out perpendicular slopes, okay, is to flip the fraction. So flip the fraction and change the sign, okay? Flip fraction and change the sign. Yeah, it's a sign, all right. Going out of business. Okay, so let's go through a series of equations and, go through and, determine if lines are parallel, perpendicular, or what's going on. Okay, so we want to see, are these lines GH and G prime, H prime perpendicular? Why or why not? And so let's go through and let's just calculate the slope between H prime and G prime, okay? And this is a slope going from -5 to 4, that's a distance of 9. The vertical distance is from 2 to 4 is 6, okay? So the slope of G prime H prime, okay, is equal to, what is that? Positive 6 over 9. So that simplifies down to 2/3, okay? Now, if we find the slope of GH, okay, then we just want to go over and up, okay, create that right angle. And so we see here that we go from 4 to -2. This has a distance of 6, and I have a vertical distance from 4 to -5, which is 9, -9. So this is -9 over 6, which can simplify down to -3/2. And so these two different slopes, okay, these are opposite reciprocals, okay, opposite reciprocals, all right? And that means that the lines are perpendicular, okay? So are they perpendicular? Yes, their slopes are negative reciprocals, okay? And that's what we're looking for, all right? So that's it. And all you have to do is just draw a picture, okay? Okay, so now, given the line y equals -3/4 x minus 2, we want to graph the line that is parallel to it and that passes through the point 1, 2. Now, what we tell from this, okay, all these equations, and we'll learn all about this next unit, all these equations like this are in slope-intercept form. So we've got this y equals mx plus b, where m is equal to your slope, okay? And so what I can tell from here, all right, And all I'm being asked to do is just graph that line. Okay, my slope m is equal to -3 over 4. Okay, so first of all, if it wants to be parallel, I know it has to go in this direction. Okay, but to going from one point to the next, all that means is I'm going to go down 3 units. So 1, 2, 3, and then over 4. 1, 2, 3, 4. And that's my new point. And then when I connect these points, all right, that's all I'm doing is just drawing that line. Okay? Same thing down here. Now this one says it wants something that's perpendicular. Okay? So again, we can tell that my slope is the number that's in front of the x value. So if my slope is equal to -3/4, then I'm looking for a perpendicular slope. Okay? Which means that I flip the fraction and change the sign. So this was negative. That means that my perpendicular slope is positive, and we flip our fraction. So I've got a positive 4/3. So that means I'm going to go down 4 units. So 1, 2, 3, 4, and then over 3. 1, 2, 3. And I'm going to plot a point right there. I'm going to connect these two with a line, and that's it. And we know that those are perpendicular because they're opposite reciprocal slopes. Okay? Okay. Now, on this one, it's asking us to consider the graph of the line y equals 1/2 x minus 4. And that's over here. That's this line right here. And so what we know, it says that the slope of a line parallel to the given line would be the value here, that's 1/2. So I know that my slope would be 1/2, okay? And then it says a point on the line that's parallel to the given line would be what? So what I want to do is I want to start here at this point, -4, 2, and I want to go up 1 over 2. I'm going to go up 1 over 2. I could say that the point on the graph that would be parallel to this point, okay, would be the point 0, 4. Okay, there's a number of points you could do, but I know that this point would be 0, 4. Okay, now if I want a perpendicular slope, okay, my original slope is m equals 1/2. My perpendicular slope is equal to -2 over 1. Okay, so I know that my slope is just going to be -2. Okay, and if I were to go down 2 and over 1, okay, that would give me the point of -3, 0. Okay, we can just draw that line right there. All right. And that's what we got, okay? So pretty simple stuff we've probably seen before, okay? Now, we also want to go back and recall that slopes of horizontal lines have a slope of 0, and that vertical lines have an undefined slope. So all horizontal lines are going to be parallel to each other. So if you've got a horizontal line like the line y equals -1, which is a horizontal line that goes through the point -1 on the y-axis, same thing with the line y equals 4. Okay, that line is going to go through the point 4. Both of these lines have the same slope of 0. Therefore, they are parallel. Okay? And then all vertical lines are parallel to each other as well. Okay? They have an undefined slope. We cannot define the slope because we have a rise, but our run is 0. And if we divide rise over run, if we're dividing by 0, that doesn't happen. Okay? So if you have x equals a number that's a vertical line through -2 and x equals 3, it goes through 3. So, but what we also know is that these lines here are perpendicular to each other, okay? And remember, this all stems from the idea of a positive slope, a negative slope, a 0 slope, and an undefined slope, okay? So if it's going horizontal, which means the horizon line, then the slope is 0, but if it's going up and down, then it's undefined, okay? All right, on this one, we have this thing called the perpendicular transversal theorem. And it says if two lines in a plane are perpendicular to the same line, then they are parallel to each other. And that kind of goes along with this idea. So if I know that, I've got two lines here, and I've got a transversal, and if I know that this is perpendicular, then this is perpendicular. Okay, if both of these angles are 90 degrees, then what I have to realize is that both of these lines are parallel, okay? And so you can come in here and you can put the little notation in there that these lines are parallel, okay? So if they're perpendicular to the same line, then you know that they're parallel, all right? Now on the next one, okay, it says use a diagram to answer the questions. Is line M, so here's line M, parallel to line N, okay, and explain why, all right? And so, if I were to, find the slope of these lines, okay, I know that this slope here going from one point to the next, okay, this goes from, this has a -7, and this has a value of 4. If I did from this point to this point, I know that this is, so this has a slope of, what is that, -4 and then 2. So the slope, okay, and let me write this, the slope of M, slope of line M, is equal to -7/4, okay? The slope of line N is equal to -4/2, okay? So -4/2. So these are not parallel, okay? And that's okay, okay? We're just trying to see if they are parallel or not, okay? So they're not parallel. But let's see, is line M perpendicular to line K? So let's find the slope of line K, and going from one point to the next, okay, this is a distance of 7, and this is a distance of 4. So the slope of line K is equal to +4/7. And so these two, all right, these two are opposite reciprocals, all right, opposite reciprocals. And so that means that they are perpendicular, all right, and that's all right. The other one says parallel line transitivity theorem says that if two lines are parallel to a third line, then they are all parallel to each other. So if E is parallel to F and F is parallel to G, then we know that E is parallel to G. So these, these are all going to be parallel to each other. So it says if line B, okay, over here on this last one, okay, if line B is perpendicular to line A, okay, here's line B and line A, and line C is perpendicular to line A, okay, what is the slope of line C? So the slope of line C is the same slope as line B, okay? So what we can say here is if we go and find the slope of line B, all right, that means I'm going to go up and over, and so this is a slope of up 5 and then over 5, okay? And what the thing of it is that you can't really tell any points that are on line C, okay? So you have to use this idea of if these two are perpendicular and these two are perpendicular, then these two have to be parallel. So this slope of line B, this slope M would be 1, so the slope of line C would have to also be 1, okay? So hopefully this is kind of a review for you. It's not too terrible stuff. It's just a lot of, just knowing how to calculate slope and what that all means. So hope you enjoyed this video. I had a lot of fun making it, and we'll see you soon. Thanks. Bye.